Yabba dabba doo! Welcome, boys and girls, to video lesson 4-1 Polynomial Functions. Okay, a polynomial function is a series of algebraic terms where we have a power of x, and these powers of x, all must be whole numbers. In other words, they can't be fractions and they can't be negative. This is an example of a polynomial function right here. The highest power of x, in this case it's 3, that's the degree of the function, so this is a third power polynomial. The leading coefficient is always going to be the coefficient of the highest power of x. And behaviors, we're going to talk about these in a minute, but these are going to be the behavior of the function on both the right side and on the left side. Okay, and these and behaviors could either be up or they could be down. Okay, so once again here is an example of a polynomial function. Its degree is determined by the greatest exponent. So in this case, it's a third power, which we also call an odd power. Okay, the polynomial function must have the leading coefficient not equal to 0. In this case, it's 5, and more importantly, it's a positive 5. The exponents are all whole numbers, as we said. And notice now, so this is not an example of a polynomial function because the exponent is -3. This third power polynomial will have at most 3 roots. We'll have at most 3 roots, and remember, the roots or the zeros are where the function will cross through the x-axis. So this will cross through the x-axis at most 3 times. Okay, let's talk about some polynomial functions with different degrees. The first 3 you already know about. If the degree is 0, we know we call this a constant function. Okay, so we have a constant function right here. It might look like something like y equals 3. That's a constant function. Notice that the power is x to the 0, which is just 1. And this passes through the x-axis 0 times because it has a degree of 0. So it has at most 0 roots. Okay, next up is a linear function. It has a degree of 1. Y equals mx plus b. We know it makes a line. Notice that we have at most 1. In this case, we have exactly 1 root. It's right there because it's a power of 1. So there's at most 1 root. And let's also talk about our n behaviors. If you look here, this goes on the right-hand side, this goes up. And on the left-hand side, this goes down. This is a linear equation of odd degree. It's an odd degree of 1, so the n behaviors are always going to be opposite if the degree is odd. Okay, next up we got a quadratic function, which you know has a power of 2. F of x equals ax squared plus bx plus c. Notice that this passes through the x-axis at most 2 times. It could be less, but it's at most 2 times. And our n behaviors of an even function are always the same. So 2 is even, so this is an even function. Notice in this case our n behaviors are both up. If the leading coefficient were negative, like if I had y equals -x squared, my parabola, of course, would be upside down. And because it's an even function, our n behaviors are both the same. They're both going down. But now they're both going down because it was a negative function. Next up is a cubic function. That's a power of 3. Notice it passes through the x-axis at most 3 times. It could be less, but it could pass through the x-axis at most 3 times. Notice my n behaviors is up on the right. It's up on the right. Let me get my pen here. Up on the right and down on the left. Because this is an odd function, the n behaviors are opposite on either side. Of course, if this were a negative third power function, like for example, I might have y equals -2x to the third plus some other stuff, my function would be reversed. It would look something like this, where the n behavior is up on the left and down on the right, but notice the end behaviors are still opposite of an odd-powered function. A quartic function is a fourth power function. The degree is 4. 4 is even, so our end behaviors are going to be the same. You can see it goes up on both sides. Notice again, there are at most 4 roots. There could be less, but there could be up to 4 roots or 4 places where the graph passes through the x-axis. If I had a fourth power function whose leading coefficient were negative, my graph might look something like this. And now it's going to be down on both sides. Down, you see its end behavior is down on the left, down on the right, but they're the same because it's an even function. A fifth power function is a quintic function. A quintic function, fifth power. Notice it passes through the x-axis at most 5 times. It could be 5 times. My end behaviors are opposite. They're opposite because it's an odd function. Notice that it goes up on the right and it goes down on the left. So you guys tell me right now, is this a positive fifth power function? Is my leading coefficient positive, or is it negative? It goes up on the right and down on the left. They're opposite because it's odd, but I want to know, is it positive or is it negative? Okay, just to review real quick, if you have an even powered function, the end behaviors are the same. If you have like a second degree function, the end behaviors are up on both sides. If it's a positive leading coefficient, and it's the same on both sides, down on both sides if it's a negative coefficient. A fourth power function, boom, there it is. But again, if it's positive, it goes up on both sides, and if it's negative, it goes down on both sides. Odd functions, the end behaviors are opposite. So here are some odd functions. The end behaviors are opposite. If it's a leading coefficient is positive, it's up on the right, down on the left. Again, in the third power, it's up on the right, down on the left. A fifth power, up on the right, down on the left. Notice that the end behaviors are opposite. If it's a negative leading coefficient, then it's down on the right, up on the left, down on the right, up on the left, down on the right, up on the left. So these last couple of pages we just went through were all in your book. If I went too fast, they're all in your book in section 4-1, section 4-1. So go ahead and look at those if you want. A couple questions that you may want to think about. An even degree polynomial may or may not cross the x-axis. Think about why. And an odd degree polynomial will always cross through the x-axis at least one time. Why? Okay, you guys do have this slide in your notes, so go ahead and fill in the degrees for each of these different types of polynomial functions. And also, you may want to make a little spot right here. What do the end behaviors look like if the polynomial is positive, and what do the end behaviors look like if the polynomial is negative? Okay, so a constant function, of course, has a power of 0 and it's flat, whether it's negative or positive. Okay, a linear function is an odd power. The degree is 1, so if it's positive, it goes left. On the left side, it's down, and on the right side, it's up. And if it's negative, it's up on the right side. Up on the left side and down on the right. Quadratic function, set second power, up. Negative would be down, etc. Okay, these are your steps to graph a polynomial function, making a rough sketch. Remember, you can always make an XY chart for any type of function or any type of graph to help you make a graph. But, here are your steps to graph a polynomial function. What type of polynomial function? Odd or even, leading coefficient, most importantly, positive or negative. Those are going to tell us our end behaviors. If you want to calculate the y-intercept, just plug in 0 for x. Okay, plot any zeros if you can see them, etc., etc. Oh, game. This game is called Graph the Function. Okay, so this polynomial function is actually a third powered function. It's in factored form, so we wrote out the factors here for you so that you can see your zeros. Okay, but this is a third power function, so it's odd. So we already know now. Let me get my marker here. It's third power, which is odd. My end behaviors, well, my leading coefficient is positive, so my end behaviors are going to be down on the left, up on the right. I'm going to have a root at -3. This factor gives us a -3, and I have a double root at 2. So I'm going to do a -3 right here. I have a root at 2, and now if I have a double root, that means that my graph is going to bounce off the x-axis. It's going to bounce off the x-axis there. So this is going to go down on the left and up on the right. Before I even do that, though, I'm going to find my y-intercept. I'll do that in blue. I'm going to plug in 0 for x. So I'm going to have 1/6 times 0 plus 3, which is 3, times 0 minus 2, which is -2 squared. So I have 1/6 times 3 times 4. Well, 1/6 times 3 times 4 is 1/6 times 12, which is 2. So I have a y-intercept at 2. So my graph now is going to go down on the left. It's going to do something like this. I come up here, go through that y-intercept, and it's going to bounce off my other root, and it's up on the right. So in this guy right here, I got f of x, which is y, is equal to x times an x plus 2 squared times an x minus 1. So as you can see now, I have 1, 2, 3, 4 x's. So this is a fourth power function. Whoop, I was getting my marker here. It's a fourth power function, which of course is even. Okay. And my leading coefficient, you can't see it there because it's 1, so I have a positive graph, so I know my end behaviors are going to be up on the left and up on the right. I have a root at 0 for the x. I have a double root at -2 for x plus 2 squared. So I'm going to have a bounce there. And I have a root at 1, which is right there. Okay, and my y-intercept, I'm going to plug in 0 for x, so I have y equals 0 times 0 plus 2 squared times 0 minus 1, which is -1, but it doesn't matter here. I have 0 times 4 times -1, which is 0, so my y-intercept is also at 0. So I know my end behaviors now. I'm going to have a bounce right here at -2. It's going to go through that spot and then up through there like that. So I have a graph that looks something like that. Notice my end behaviors now. My end behaviors are up on the left, up on the right. I have up to 3 roots. I have a double root right here. And it goes through these two x-intercepts as well. My y-intercept was 0. Okay, you guys are going to try this one right here, but before we do, let's just decide on our power. Let's decide on our power. Let's decide whether it's positive or negative. Decide on your roots, which are your x-intercepts, and are any of those roots doubles. And you're going to find your y-intercept. You guys go ahead, and I'll be right back. Okay, you should have found that the power was 3 because I have an x squared times an x. In this case, now my leading coefficient is negative. So it's negative, which means my end behaviors are up on the left and down on the right. I have a root of 0, and in fact this is a double root because it's x squared. I also have a root of 4. That comes from this factor right here, which means now if I throw in 0 for x, I'm going to get 0 times -4, which is still 0. So my y-intercept is 0. That's also a root. I have a root of 4. Because this is a double root, I have a bounce. So it's up on the left, down on the right, and I got something that looks like that. All right, folks, that's it. I hope you had a good one, and we shall see you soon.